Okay, this is three-wire circuits part 3. In this little mini episode here, we're going to look at the results of a three-wire circuit that has a failure in one of its line conductors, maybe due to a bad breaker or a bad fuse or an overload that happened at some point in time. But the results that can potentially happen if we only have a line and a neutral connected to the remainder of the circuit, okay? So we've lost our line 1 to line 2 potentials out here, all right? So the first thing I'm going to say is we should analyze maybe, or we should look at first, is this a balanced or unbalanced three-wire? I would say it's a balanced because we got 120 watts of lighting on each of these, okay, and the 240 here. I'm not going to go through the procedure of mapping out the current in the way it would have been normally. I'm going to move right ahead to opening up our line 1 conductor, okay? And if I open up our line 1 conductor, we're going to ask you on an exam or on a quiz, we're going to potentially ask you what a voltmeter would read across that break, okay? In order to identify what that would read, we need to do a couple things. We need to analyze the circuits or the portions of the circuit that would be affected by that break, okay, and the ones that would be unaffected. The affected ones, we need to solve for what the resistances of those loads would have been prior to the break actually happening, okay? So this would have seen 120 volts at it normally, okay? Is this load down here affected by the break at line 1? The answer to that would be no. It has a line 2 to neutral potential across it, so that one is still operating normally. We don't have to do anything with this load here. Over here, and this one, we have to look at how current could potentially flow. If we were to leave the line 2, okay, we have current that would head this way and then back to the neutral, okay, but then it also has a potential to flow this way, back through that lighting load and back to the neutral there, all right? So before the break, that lighting load would have seen 120 volts, okay? So if we looked at 120 watts divided by 120 volts, that gave me a circuit current there of 1 amp, okay? And we could go 1 amp divided into 120 to give me 120 ohms of resistance for that lighting load prior to the break happening. That resistance won't change. Here, we've got 2400 watts. We would have seen 240 volts across it, so we're going to look at 240 volts divided into that. That should give me, what is that going to be? 20 amps? Is that right? Or no, 10 amps. Sorry, bad math. 10 amps. So we would have had 10 amps of current flow, okay? And then 10 amps divided into 240 will give me a resistance of 24 ohms. Okay? Just double check my math here. 240 divided by 10, 24, okay? So we're okay with that so far. All right, so next, we can look at this circuit here on its own, because now that's a series circuit. Here's my line 2, going to come up through a baseboard heater, through a lighting load, and then back to neutral. Okay, we only have a 120 volt source there. Okay, we had 24 ohms here that we just figured out. And we've got 120 ohms here, giving us an R total for this circuit of 144 ohms. We're going to divide that into our 120. That'll give me 0.833 amps. Okay? Utilizing that current, we can multiply it by one of our loads. So I'm going to multiply it by my 240 volt load. That tells me my 240 volt load sees only 20 volts across it. Okay? And that would mean if we went the 0.8333333, multiplied that by 120, that gives me basically 100 volts here. Okay? So if we bring that information back over to here, we no longer have 240 here. I'm going to choose a better felt. We've got 20 volts here. And over here, we no longer have the 120. We've got 100 volts here. Okay? So, solving for this answer here can be done one of two ways. The answer should be exactly the same. It will be, what are we looking at? It will be the 120 volt potential plus the 100 volt potential here. Okay, in other words, looking at this and this. Okay, so 120 plus 100 to give me 220 volts. That's the potential difference between these 2 points. Or the better way for us to look at it might be if we've got a 240 volt source and we're dropping 20 volts here, okay, then the difference between 240 minus the 20 will be 220 volts. Okay, the numbers should be the same. You either add the 120 or the old 120 volt load plus the good intact 120 volt load to come up with the answer, or you take the 240 volts and subtract what the original 240 volt load is now drawing. Okay? Either way, it should come up to the same number, and that'll be your answer up there. These ones can be a little bit difficult for me to explain or understand. However, I will say that that's how it's going to work. Okay? So we will also explore this a little bit in the Learning Hub. Okay? So that is exploring a open line conductor on a 3-wire circuit. Now in this case it was a balanced 3-wire circuit. If it was unbalanced, we would approach it exactly the same way. We still have to solve for the rated resistances before the break. Okay, do the math over on a separate circuit in a series portion and then be able to come back, okay, and rework it. All right, so that ends this one.